This video lesson will teach you to define the angle bisector theorem, use ratios and proportion to verify angle bisectors, identify angle bisectors using the lengths of the sides of triangles, find the unknown lengths of sides of triangles. Let's start. What is an angle bisector? The angle bisector theorem helps you find unknown lengths of sides of triangles because an angle bisector divides the side opposite that angle into two segments that are proportional to the triangle's other two sides. How can I construct an angle bisector? Start by drawing triangle ABC on a piece of paper. Interior angles A, B, and C have opposite sides, lowercase a, b, and c. Get some linear object and put one endpoint at angle A. Allow its other end to cross side A. Divide angle A into two equal angles. You bisected angle A. The linear object is an angle bisector. When it crossed side A opposite angle A, it divided triangle ABC into two smaller triangles and divided side A in two. Now replace your object with a drawn line segment or ray. When the angle bisector crosses side A, label that point D. The angle bisector is now line segment AD and creates two smaller triangles, triangle ACD and triangle ABD. Side A is now two line segments, CD and DB. What is the angle bisector theorem? An angle bisector of a triangle divides the interior angle's opposite side into two segments that are proportional to the other two sides of the triangle. Angle bisector AD cuts side A into two line segments, CD and DB. CD and DB relate to sides B and C in the same proportion as CA and BA relate to each other. Triangle ACD and triangle ABD, created by the angle bisector, are also similarly proportional. What are ratios and proportions? Ratios compare values. You can establish ratios between sides CA and BA and line segments CD and DB. Proportions compare ratios. You can learn if two ratios are equal. For triangle ABC with angle bisector AD, sides CA and BA, and side A divided into CD and DB, we can set up ratios between the sides and line segments and compare them. CD to DB equals CA to BA. Line segment CD from angle bisector AD has the same ratio to line segment DB as the triangle side CA has to side BA. Be careful to set up the ratios correctly. CD is the smaller of the two line segments, so it is the numerator of our ratio. DB is the longer line segment, so CD is to DB as the triangle's shorter side CA is to the triangle's longer side BA. Other ratios emerge too. Compare line segments of the side divided by the angle bisector to the remaining sides. CD to CA equals DB to BA. The relationship of the two sides of the new smaller triangle CDA is the same relationship as the two sides of the new smaller triangle DBA. They are in the same proportions. How do you know a line segment extending from an interior angle is an angle bisector? You check the ratios. Suppose we are told a line segment AD divides side A into CD and DB of lengths 10 centimeters and 30 centimeters. We are also told side CA is 30 centimeters and side BA is 90 centimeters. Let's see if the ratios are proportional to each other. CD to DB equals CA to BA. Now let's plug in our numbers. 10 to 30 equals 30 to 90. We see 10 to 30 is the same ratio as 30 to 90, so AD is an angle bisector. Now let's use the angle bisector theorem to find an unknown side of a triangle. If we know the length of original sides A and B, we can use the angle bisector theorem to find the unknown length of side C. The angle bisector divides side A into CD and DB. Let's assume these lengths. CD equals 10, DB equals 20, CA equals 25. Recall our ratios. CD to CA equals DB to BA. Now substitute the values. 10 to 25 equals 20 to BA. Using cross multiplication, 25 times 20 equals 500, and then division. 500 divided by 10, we get BA equals 50 meters. Lesson summary. We are now able to define the angle bisector theorem, use ratios and proportions to verify an angle is a bisector, use the angle bisector theorem to find the unknown lengths of sides of triangles, and identify an angle bisector by evaluating the lengths of the sides of the triangle.